Variable pitch constant speed propellers allow the adjustment of RPM for changing TAS and flight conditions. Separate power levers, throttle, and RPM control levers are provided so that it is possible to vary one whilst leaving the other constant. A selected RPM can be maintained and braking feathering facilities may be incorporated. A constant speed unit or propeller control unit automatically varies blade angle and therefore angle of attack so that the selected RPM can be maintained even though speed and engine manifold pressure may themselves change. Here's a diagram of the different blade angles a variable pitch propeller can achieve. At 0 degrees, the propeller is in line with the plane of rotation. If it moves slightly forwards, it would reach a point called ground fine, and further than that, flight fine. Flight fine is where the alpha range commences. It's a constant speed range up to flight course. Beyond that, the propeller can achieve a blade angle of up to 90 degrees in the feathered state. In the beta range, the propeller is now behind the plane of rotation as much as 20 degrees and can provide reverse thrust or braking. The centrifugal latch prevents blades from moving to the feather position when the aircraft is on the ground and the engine is switched off, due to a leakage of oil through the CSU relieving pressure in the pitch change cylinder. The centrifugal force disengages the latch at all speeds above ground idle. On start-up, oil pressure builds up to move the propeller blades to the fully fine position. Counterweights on a single-acting variable pitch propeller try to move the blades to coarse pitch. The centrifugal twisting moment tries to move the blades to fine pitch. The CSU oil pump boosts the oil pressure from the engine lubricating system sufficiently for the operation of the propeller pitch change mechanism. To feather a single-acting variable pitch propeller, RPM lever is moved fully aft to the feather position. Oil drains from the propeller and blades turn to the feathered state under the action of the propeller counterweights and spring. To unfeather a single-acting propeller, a separate source of oil under pressure is required. On light aircraft, this is provided by an accumulator which is charged during normal flight. The pilot's RPM lever is moved into the constant speed range which releases oil from the accumulator, allowing it to flow to the propeller. Once the propeller starts to windmill, normal oil supply completes the operation. In the on-speed condition, spring force is balanced by flyweight force, and oil ducts to or from the pitch change cylinder are blocked off, i.e. a hydraulic lock is formed. Constant RPM is maintained. In the overspeed condition, the flyweights move outwards and raise the governor valve against spring pressure. Oil drains from the pitch change cylinder to increase pitch. In the underspeed condition, the flyweights move inwards and the governor valve is pushed down by spring pressure. High pressure oil enters the pitch change cylinder to decrease pitch.